Okay, this worked example concerns a sample of students from a class. So let's just get into it here. We're looking at their hair color. Okay, so in a class of 20 pupils, 11 have dark hair, 7 have fair hair, and 2 have red hair, and that accounts for all 20 students. 2 pupils are chosen at random to collect the homework. Okay, what is the probability that both have fair hair, and what is the probability that each has hair of a different color? Okay, so we've got A and B there. So let's just sort of look through the problem and just sort of digest it a little bit. So let's denote D for students with dark hair, and that's 11 pupils. F for pupils with fair hair, which is 7 pupils, and R for pupils with red hair, which is 2 pupils. I'm using pupil and students interchangeably, but really I should just stick with pupils and be done with it. So 2 pupils are chosen at random to collect the homework. Okay, so we have D, F, and R there, and we have a count for each of them, 11, 7, and 2, and that adds up to 20. Okay, so what is the probability that both students have fair hair? So there are the number of ways to choose 2 fair-haired students out of 7 is as follows. So we have a binomial coefficient. What we're going to do is from the 7 students, 7 fair-haired students, pupils, we're going to choose 2 of them. So we're going to use a binomial coefficient formula here. And that is 7 factorial divided by 2 factorial times 7 minus 2 factorial. Here n is 7. K equals 2, and n minus k is 7 minus 2, which is 5. 7 factorial divided by 5 factorial gives us 7 by 6. So we end up with 7 times 6 divided by 2 times 1. That is 21. So there are 21 ways to choose 2 fair-haired students out of 7. Okay. The total number of ways to choose 2 pupils out of 20 is 20, choose 2, from 20 choose 2. Here n is 20 and k is equal to 2. 20 factorial divided by 2 factorial times 20 minus 2 factorial, which is 18 factorial. And again, 20 factorial divided by 18 factorial gives us 20 times 19. So 20 times 19 divided by 2 times 1 is 190. By the way, this is a counting problem so far. So essentially this marks the transition from a counting problem to a probability problem here. The probability that both pupils have fair hair is as follows. P, both have fair hair, is 21 divided by 190, which is approximately 11%, 0.1105. Perfect. So that's exercise A. So what is the probability that we have 2 students with different hair color? So essentially what we have to do is break this up. There are 3 types of hair color in the class. So what we're going to do here is look at it from the point of view of choosing 1 dark-haired pupil and 1 fair-haired pupil, or 1 dark-haired pupil and 1 red-haired pupil, and then finally 1 fair-haired pupil and 1 red-haired pupil. Okay? So essentially what we're going to do is look at these and then just combine them into a single outcome, which is they all have different hair colors. So, or looking at it the other way, the fact that they all have different hair colors is a combination of these 3 possibilities. Okay, so 1 dark-haired and 1 fair-haired. So we have 11 dark-haired students and we want to pick 1. So from 11 choose 1, which is actually just 11. And from 7 fair-haired students, we choose 1. So there's 7 ways of doing that. So 11 times 7 is 77. So there are 77 ways we can pick 1 dark-haired student and 1 fair-haired student. Okay. So what about 1 dark-haired student and 1 red-haired student? So it's similar to the previous instance, but in this case, we just have 2 ways to pick out a red-haired student, a red-haired pupil, because there are just 2 of them. Okay. So you pick one or the other. And there are 11 ways we can pick out a dark-haired student, which is from above there. So you have 11 times 2, which is 22. So just using the 2 numbers that we've calculated previously in this first and second part of that, we know that choosing 1 fair-haired student, there's 7 ways to do that. And 1 red-haired student, there are 2 ways to do that. So altogether we have 7 times 2, 14 ways of picking out 1 fair-haired student and 1 red-haired student. And I'm keep using student. I apologize for that. Anyway, the total number of ways to pick two pupils, as I keep what I should call the students, or the pupils, anyway, is the total number of ways to pick out two pupils with different hair colors is 77 plus 22 plus 14, which is 113. So the probability that each pupil has different hair color is 113 divided by 190, which is approximately 59.47%, 0.5947. Okay, that's it. We'll leave it there.